Hi, it's Dr. Sandy Laura Kramers. Thank you for joining us for the Eye Show podcast. If you're listening in because your eyes are hurting, they're stinging, you're in pain, please do not give up hope. I know it seems sometimes like there's no hope. You've tried every drop, you've tried every procedure, and nothing is helping. We just need you to hold on for a few more months, maybe a couple of months. We have wonderful, exciting research to share that I want you to all be aware about. Your eyes are not done healing, and your glands are not basically dead necessarily. And so the idea is that we're trying to save the orifice of the meibomian gland and the other cells for what's coming next. And today I want to go through what this groundbreaking research is all about. So some of you have heard of Dr. David Sinclair. He's a Harvard scientist that has been working on longevity and basically reversing aging for years. And some of the research he's showing is very exciting because it can translate into dry eye disease and even glaucoma and blindness and macular degeneration. So let's talk about that today. So let's start with the idea of what is really happening. His idea is called information theory of aging. And what Dr. Sinclair has been doing is basically doing aging experiments where he notes that the DNA is the hardware and is mostly intact for most people, but what he's trying to change is the epigenetic software. And that's the instructions that tell your cells who they are and what they're supposed to do. So what is epigenetics? Epigenetics is the system of chemical tags and switches that sit on top of your DNA. The epi means on top of, and these tags don't just change, they don't change your genes, they just change the way your genes are basically read. So you can think of the DNA as a piano, and the keys never change on the piano. But the epigenetics is the pianist who's basically deciding what keys to play. And so basically the idea is in what order, so that's kind of what epigenetics is all about. And so if the pianist becomes confused and the music becomes chaotic, that's aging, and often we'll say inflammaging. And the idea is that as we have more inflammation, the piano keys are all over, basically the pianist is not making any sense. You could also think of it kind of like as a library. You have a bunch of books that are there, and the epigenetics is like the librarian that knows where the books are that you need and when. And it basically is trying to make these books read in a proper order so you don't age. So basically what we're trying to do is change epigenetics to slow down the aging process and even reverse the aging process. So when epigenetic information becomes corrupted, cells lose their identity, they don't know what to do, and a meibomian gland cell forgets to make the oil. The cornea cell forgets to signal properly. That's why you can get pain even without stain. A retina cell forgets to process things properly, and you can have blindness. And so that's what we're trying to do, is change the epigenetics. So with his research, what he's showing is that you can actually change the genes in these cells. And so his lab is showing that you can reset the age of the cells by about 75%. And they're using this with a subset of what's called Yamanaki factors. And these genes are inserted through viral vectors into a cell. So you think of, like, let's say your piano has the piano keys that's starting to maybe not work properly. You're inserting it into the actually key through locks and keys, and basically you're having it read in a different way so it doesn't malfunction. And so in mice, he's been showing that you can reverse aging in the skin, for instance, and muscle, and now they're about to insert it into the optic nerve, which means that we could possibly reverse blindness or prevent blindness even in glaucoma patients. So the first human studies are about to occur. They've been doing it in primates, which are similar to humans. And we're talking about whether we could do this into the meibomian gland. So this is the next generation of regenerative ophthalmology. So if you have dry eye disease, it's not just dryness, it's really inflammation, nerve dysfunction, gland atrophy due to inflammaging. And now what we're trying to do is reverse that. That's the next step, the next new things. So when we say meibomian gland dysfunction and the glands are getting inflamed and the oil is drying up, the orifice sometimes will close completely. And that's what we're trying to save. So we need patients to just hold on, keep those orifices open, do those warm compresses if you can, blinking. Intense pulse light is an anti-inflammatory. probing is to keep the orifice open so we can then start using this gene therapy. One note, I want to talk about doxycycling, and it's not just an antibiotic, as hopefully you've heard on my previous podcasts, but at a low dose, it works as a gene modulating anti-inflammatory molecule. It inhibits MMPs, which are these basically enzymes that accelerate aging. It reduces inflammatory cytokines. It stabilizes the lipid layer. And now Dr. Sinclair and his team are using doxycycline to turn on and off these genes that they're inserting. So it makes it very exciting because doxycycline is super safe. So doxycycline can influence gene expression by reducing oxidative stress and inflammation. And these are the two biggest drivers of epigenetic changes. So when we say try doxycycline, we mean it. And I used to say I would basically put doxycycline in actually water at 20 milligrams because it's so safe. And that's what was being used at Harvard for years in cancer patients to decrease inflammation. But now we know doxycycline can really actually help your genes work better. So it's not working as an antibiotic at 20 milligrams, it's working as an anti-inflammatory, and it's helping your genes work better. So the future now is gene therapy for meibomian glands. And so the idea is that if Dr. Sinclair's research on humans is working for the optic nerve, we can then maybe regenerate these glands, the meibomian glands that produce oil, the lacrimal glands that produce water, and even the mucin layer that produces mucin to help those genes, those cells, the genes in those cells express the proper protein to be able to give you symptom relief. So the door is opening wider for all these amazing treatments that are around the corner. So we're very excited. As you know from my research, we've inserted already stem cells, we've inserted cord blood serum, we've inserted platelets into the meibomian glands, and I am super excited to potentially start working with Dr. Sinclair's team to insert these genes into the meibomian glands, or somebody should. And so as we do these intense pulse light treatments, all these anti-inflammatories, we're trying to keep the oil pumping for as long as we can, unless we need a major kind of change of the motor, in which case we would start thinking about gene therapy. So I hope you find this podcast helpful. Please send it to everybody you know. Just let them know there's a lot of hope. This is groundbreaking, and it means that the symptoms you're having may be a temporary problem. Even having to use drops all the time or having to do these procedures all the time may not be forever. If we can reprogram these cells to rejuvenate and work as a younger version of themselves, it's incredibly exciting. So in the meantime, warm compresses if you can, blinking, try not to be on the screens too much, your blue light protection. Please check out our other podcasts because we know we have possible treatments that are not just anti-inflammatory, they're not just healing, they're rejuvenating and maybe even bringing back your cells to what they were 10 years ago. So please be hopeful. We're not a guarantee yet, but very close. So I hope you found this podcast helpful. Have a great day.